Welcome students. You are already familiar with rational and irrational numbers, and also you know very well the set of all rational and irrational numbers is called real numbers. Shall we see some examples for irrational numbers and rational numbers? Rational numbers. Example 3, -5, 0, 2 by 3 and -2 by 3. Examples for irrational numbers. Example √2, √3, √3 plus √3, 2 plus √5 and root of 2 by 3. In all these irrational numbers, the symbol of root has been used, isn't it? Do you know the name of this symbol? I informed you to read the radical notation in book page number 57. If you see in that page, you will know the answer of this symbol. It is called a radical symbol. This symbol is called a radical symbol or sign. Okay. You know very well 1 square is equal to 1. 2 square is equal to 4. 3 square is equal to 9. 4 square is equal to 16. Like that. 1 cube also 1. 2 cube is equal to 8. 3 cube is equal to 27. 4 cube is equal to 64. 1 power 4 is equal to 1. 2 to the power 4 is equal to 16. 3 to the power 4 is equal to 81. 4 to the power 4 is equal to 256. Here 1 to the power 5 is equal to 1. 2 to the power 5 is equal to 32. 3 to the power 5 is equal to 243. 4 to the power 5 is equal to 1024. Here you see the pattern 1, 2, 3, 4. These 4 numbers only we are taking here, and also the square of this number, cube of this number, fourth root of this number, power 4, power 5. See here, we can write it as square root of 1, square root of 4, square root of 9, square root of 16. See here what will be the answer. Here 1, here this 2, here 3 3s are 9, so 1 3 will be the answer. 4 4s are 16, so 4 is the answer. Like that. See here also 1 will be the answer. If we divide 8 into 3 equal parts, you will get 2 into 2 into 2. So 1 2 is the answer. Okay, you know already, just I am recalling this. If we divide 27 into 3 equal parts, you will get 3. 3 into 3. 3 3s are 9. 9 3s are 27. Here 64, cube root of 64 is 4. The same way here also, here 2, here 3, here 4. 1, 2, 3, 4. If we extend like this, you will get one general term. This is square root, cube root, fourth root. This is fifth root. If we sixth root, seventh root, like that, if we extend means at last we will get nth root. Nth root. We write it as nth root. Okay, it is given in your book. Page number 57. Nth root. Nth root of, like that you have to read. If we write a number using this notation, it is called radical notation. Radical notation. This is our topic. This is today's topic. There are some conditions here. If we write like this, you see, nth root. So here, what is n? 2, 3, 4, 5. These numbers are n. Otherwise, it is power. You see, these are called n. Okay. So, here n, this is x, is equal to r. If r to the power n is equal to x, r is called the nth root of x. See the examples given here. This is, already we have seen, 2 is n, 16 is x, 4 is r. Okay, 4 is r. 4 is the square root of 16. R is the nth root of x. In that way, 4 is the square root of 16. 4 is the cube root of 64. 4 is the fourth root of 256. 4 is the fifth root of 1024. Are you clear now? Okay. Let us see what are the parts in this radical notation. This n is called root index. Root index. மூல குறியீடு. Radical notation அப்படின்னா மூல குறியீட்டு முறை. மூல குறியீடு. இந்த மூல குறியீடு அப்படிங்கிறத radical notation already we have seen. So this symbol is called radical symbol. Radical symbol or sign. Okay. If we write in this form a number means it is called a radical notation. Are you clear? This is root index. This is radical symbol. This x is radicand. Okay, this r is a number. One more way of representing the radical notation is there. That is fractional index. Fractional index. Fraction means you know very well. It is written in the form of p by q. Okay. Okay, so nth root of x, we can write it as x power 1 by n. Okay, this is radical notation form. This is fractional index form. It is in the form of fraction, so it is called a fractional index form. If you please take your book, page number 58. You see the tabular column given in that last part. First one is power form. You see 1 square, 2 square, 3 square, 3 cube, 3 power 4 like that. It is in the form of square and cube, fourth and fifth. Okay, it is called power form, otherwise called exponent form. இப்போ இது வரைக்கும் நம்ம என்னன்னு சொல்லிட்டு இருக்கோம், இதை எக்ஸ்போனன்ட் ஃபார்ம் தான் சொல்லிட்டு இருக்கோம். பவர் ஃபார்ம் ஆர் எக்ஸ்போனன்ட் ஃபார்ம். This is radical notation form. The second tabular column, radical notation form. If we write with this form, it is called a radical notation form. Third one is fractional index form. Okay, third one is fractional index form. Example is given 64. We can write it as 64 to the power of 1 by 3. If you write the numbers in this form, means it is called a fractional index form. It is in the third column. Then the last one, how to read the numbers, that is given. Next, meaning of x power m by n. Here m, n are positive integers. When we interpret x power m by n, either as nth root of mth power of x, nth root of mth power of x. Already we know 1 by n, 1 by that number means that is the root value, isn't it? So this is n, 1 by n. Whichever number comes in this place, it is the root of this number. Whatever comes in the numerator is the power. Are you clear? Numerator number is power, denominator number is root. Okay, otherwise mth power of nth root of x. There are two ways we can say this. One is nth root of mth power of x. Another one is mth power of nth root of x. We didn't change the root and power. First we say the root and power next. In the second way, first saying the power and the root. Are you clear? It is in your book, page number 59. The box you see clearly. In symbols, we can write it as x power m by n is equal to x power m whole power 1 by n, or x power 1 by n power m. In other way, we can write it as in radical notation form. If you write means, how will you write? Nth root of x power m, or this is nth root of x power m. Are you clear? See the example sum 2.16 in your book, page number 59. There are 5 sums in this. Express the following in the form 2 power n. Okay, I am doing third sum and fifth sum. You have to do the remaining sums by yourself. Try it. And also exercise 2.5, first sum, second sum and fifth sum homework. See here, 1 by 4 is given. Write solution. 1 by 4 is equal to, we have to write in the form of 2 power n. So, you have to split the number into 2 in the base. Okay. So, how will you divide this? 2 2s are 4. Now, we can write it as 2 to the power 2. It is in the denominator. So, when you write it as in numerator, the power will be minus sign. So, 2 to the power plus 2 here. Here 2 to the power minus 2 is the answer. Okay, fifth sum, root 8. Solution, root 8 is equal to, how can you change it? Root 2 into root 2 into root 2. If you multiply these three numbers, you will get root 8. Okay, 2 2s are 4, 4 2s are 8. It is in the root. It will not change. See here. There are 3 numbers. Root 2 same 3. Okay. So the power of this root 2 is 3. Root 2 power 3 also we can write it. Already we have seen, instead of this root we can write as fractional index form. So 2 to the power 1 by 2 power 3. It is power, it is root. Okay. Another way we can write 2 to the power, this is power. Power means mth power of nth root. We can write like that. So 2 to the power of 3 by 2. Are you clear? Root 8 is equal to 2 to the power 3 by 2.